Welcome to lesson 71. In this lesson, you'll learn how to verify solutions to inequalities with substitution. So while I'm modeling, I want you to look out for these 4 things. 1, watch how I successfully evaluate potential solutions. You're going to do the same task in your practice today. How do I determine if a solution is successful or not? Is it a real solution to our inequality? So watch for that one. Then watch to see how I read and interpret one-step inequalities. How I use parentheses to substitute, especially if it is a coefficient. I'm going to use parentheses there. And finally, how I determine whether an inequality is true or false. Let's jump into this first practice. Which of the following solutions satisfies the following inequality? So when we say satisfies inequality, we want to know, is it a solution? That's all we're asking. Is it a solution? Yes or no? So what you're going to see me do is use substitution to see whether or not the statement is true. So let's start with the first one. You see my statement is 2 times the number is greater than 10. So let's try when the number is 0. So 2 times 0 is greater than 10. So to simplify that, 0 is greater than 10. Is that a solution? No. So it does not satisfy that first one. 0 does not satisfy the inequality. Let's try when the number is 1. 2 times 1 is greater than 10. Simplifies to 2 is greater than 10. Again, no, that is not a true statement. 2 is not greater than 10. So I substitute for the next set, and I'm doing the same thing. Is 4 greater than 10? No. 2 times 5 is greater than 10. Is 10 greater than 10? No. And again, this does not have the greater than or equal sign. It just means the expression, the term on the left is greater than the one on the right, and that is not true. They are actually equal. So 2 times 10 is greater than 10. 20 is greater than 10. So when G is 10, it does satisfy the solution. So that's how I just start off with just substituting to see whether or not the solution set over here, if these values satisfy this inequality. Now, in some problems, they're going to ask if all the solutions in the set satisfy. So in this case, if that was the question, do all of these solutions satisfy the inequality? My answer would be no, because only one solution does, 10. The rest of them do not. Let's move to the next set. Solve the inequality for G and graph. So I'm going to solve this the same way I would a simple one-step equation. So I'm going to isolate my variable, divide by 2. And I get G is greater than 5. So that is my inequality. G is greater than 5, and I'm going to graph it now. Again, I put 5 in the center, and I want all the numbers where G is greater than 5. So I'm going to put the G on the right. That's just my visual cue to know I want all the numbers to the right. 5 is not included in my set, so I circle it. And I make my arrow to the right. So I want every single number that is greater than 5. So what are some possible solutions? 5 and 1/2 is a possible solution because that is greater than 5. I can say 12. And I can try, let's try 6. And again, to simplify that and just verify it, I can go back to the original equation. 2 times 5.5 is greater than 10. So I'm going back to my original. 5.5, 2 times 5.5 is 11, and 11 is greater than 10. So please don't think that it's only a whole number. These are not just whole number integers. No, I can actually use rational numbers and fractions as well, as long as they are greater than 5. 2 times 12 is greater than 10. Yes, 24 is greater than 10, so that one works as well. And I'll go to the left for the next one. 2 times 6 is greater than 10. Yes, 12 is greater than 10. So my 3 solutions do work. Hit pause and add this to your notes. part 2, I'm doing the exact same thing. I just have a 2-step inequality at this point in time. So same thing, I'm substituting when s equals 0. 4 times 0 plus 3 is less than or equal to 12. Yep, 0 plus 3, which is 3, is less than or equal to 12, so that's the solution. I do the same thing again. 4 plus 3 is 7. 7 is less than or equal to 12. I go to the next one. Ooh, 23 is, nope, this one is not true. 23 is bigger than 12. So I can also say that the next set would also not be true because I have higher values. In this case, I have 4 times 8 plus 3, which is 35. That's not bigger than 12. And 4 times 20 plus 3, which would be 83. And that is also not less than 12. All right, so let's solve the inequality the way we would a 2-step equation. 4s plus 3 is less than or equal to 12. I will deal with our constants first. So 4s is less than or equal to 9. And let's divide both sides by 4. So I get s is equal to, see, 9 divided by 4 is 2 with 1 out of 4 left over. So s is less than or equal to 2 and 1/4. So to graph that, I just make a line. Here's 2 and 1/4. I want s to be less than, so it's going to be on the less. And I'm going to fill it in. So it can be equal to 2 1/4 and all the numbers less than that. So those are my solutions. Now, I didn't give myself a lot of room on the bottom, so I'm going to pick 2. Why don't I try some negative numbers? How about -1 and -2? Let's have some fun with this. So let's try the 2 first. 4 times 2 plus 3, and that is 8 plus 3, and that is less than or equal to 12. So 2 works. I'll try -1. 4 times -1 plus 3. So -4 plus 3, which is -1. -1 is less than 12, so that one works. And let's try -2. 4 times -2 plus 3. So -8 plus 3, which is -5. -5 is less than or equal to 12. So there you have it, even with negative numbers. So notice I can have decimals, I can have fraction numbers, and I can even use my negative integers as well. So hit pause and jot this one down into your notes.